Thank you all for coming. And as Zoe mentioned, we're going to be taking a look at remote debugging. I guess in these sort of difficult times, we want to really understand what's the best way to go about helping customers overcome problems in our applications and to be able to do that from a distance, do that remotely. So what we'll be talking about today, we'll have a quick look at, what's a typical approach to remote support right now. And we'll try and explain why, although, in many cases that works out, but in many cases it doesn't, and understand why that is. And then we'll take a look at our LiveRecorder product and seeing how we can use that to make the whole remote support workflow much more robust and much more repeatable. So let's jump right in then. So why do we care about this right now? Even we're in strange times at the moment, but even before that, it's not always practical to go to a customer and to help out, help them solve a problem with your software. And there's a number of reasons for that, right? Either distance, we can't be everywhere. Might be the number of customers. If you have a lot of customers and not enough support team availability, you're not physically going to be able to visit all of these customers. And as I mentioned, changes to just the way that we're working, such as, the coronavirus situation that we all find ourselves in. All these reasons, come up and are a problem for physically visiting the customer site. So we really need to think of ways in which we can get the same kind of feedback in terms of the information that we need to solve the problem, and that we wouldn't do if we went physically to a site, and be able to do that remotely. So what really is the challenge of doing this remotely? So probably the biggest problem is understanding what has actually gone wrong with your application at your customer's site. We don't generally have a good understanding of what their runtime environment is at the point of failure. We obviously want to understand what our application is doing when it failed. And when you're not physically in front of the computer and being able to have hands-on control over the system to sort of interrogate what's going on, then that becomes quite difficult to do. And to do that remotely, you need to have good, robust workflows which allow you to pass information back from the customer, from their system, from their failing application, back to the people who are going to be able to fix that. So R&D or developers, engineers, and so on. So gathering that debug information is a real challenge remotely. And that becomes even more of a problem when you consider particularly multi-process environments, where you may have many processes spread over many different machines. And again, being able to get an overall view of what's going on is difficult. On top of that, we have different support staff involved quite often. So being able to coordinate remotely between first, second, third line support can be a challenge, particularly if you're not all in the same office. And finally, a lot of the expectations we have as developers trying to solve these problems are based on a set of tools that we may be comfortable with. So if you find that your customers don't have those tools, it could be anything, could be perf, it could be whatever, then that's going to be a major blocker in your ability to solve the problem as quickly as possible. So remote support is a necessity, but it's actually not that easy a lot of the time to get the same kind of resolution time as you would if you were physically there. And of course, there are some other issues there which we'll get onto later on, but for now that's enough. So how are we going to solve these issues? So I guess the first thing is to understand how we can get that critical debug information back to the people who need it in order to solve the problem. So that's certainly a blocker quite often. You'll find that the information you get in the first run may not be sufficient to help you find a resolution to the problem. And then you have to go back to your customer and say, well, what else can you tell us about the issue? Even worse than that, as we'll see, when you introduce sort of fixes or extra information gathering capability to your application, getting that updated application or debug version of that application to your customer, getting them to run it and so on is, again, a big time sink. On top of that, you really want to reduce the amount of customer contact time that you have. You don't want to be bothering your customers for little bits of information over and over again. So you want to be as efficient as possible, and we want to show you how that can happen. So you want also to have support workflows that can accommodate customer-facing staff of different abilities. So you're going to have people who are very proficient with, let's say, debuggers, and you're going to have people who are more aligned with understanding log files and finding the solution that way. So you need to have a workflow that can accommodate that big range of capabilities, technical capabilities of frontline staff, and that's an important part of the workflow. And obviously, if we can integrate those debug tools that you're used to using at your own desktop into the workflow, then so much the better. It means that you'll be using tools you understand and you're comfortable with, and that's going to mean you're going to get to the resolution much more quickly. So how what do we mean when we say, smarter software, quicker resolution? The thing that we have here at Undo is a workflow which is what we call a record, replay, resolve kind of workflow. And this is part of our wider software failure replay capability that we're providing tools and workflows to support. And we'll come into this a little bit more detail in a moment, but I just wanted to introduce it here so that you have some understanding of the sort of workflows that we're suggesting. The idea is that we are able to record actually application state in a very granular, small granular fashion, and capture enough information that we can then use that information to resolve the problem in a single pass. So you don't have to have this multiple contacts with your customer. You have all the data you need to solve the problem straight away. And that's true of not just our technology, but also of any support workflow. You want to reduce the amount of contact time with your customer just so that you can get the fix to them as soon as possible. So let's have a look at some existing sort of workflows and tools that are most commonly used. And probably the two most commonly used tools are going to be logging and call dumps. So logging is generally the way that applications will capture information when things go wrong. And because of just the nature of logging, it tends to be not only information about the specific issue that you're seeing, but you're going to get lots of information about the general well-being of your application. And then from that, you hope to be able to extrapolate from that information to the point where the bug happens and the application crashes. And you want to be able to say just from your logging that, okay, there's some critical issues here have occurred and we can see them in the logging. And a lot of effort is put into ensuring that logging is but diverse and also all-encompassing. But it generally is a way of getting sort of more general information for your application. When something goes wrong, you don't always have the specific debug information to support any hypotheses you may have. Even if you have multi-level debugging, where you can switch on much more invasive information gathering, even then it's not always going to tell you exactly what happened. And in a worst case scenario, you may find yourselves having to re-instrument your application and send debug versions to your customer. And again, this is just increasing that debug cycle time, increasing the amount of touches with your customer, and increasing the amount of time to resolution. Again, second, probably most common way of gathering information about a critical failure is through call dumps. And call dumps are very expressive sources of information. The big disadvantage to them is that they occur only at one point in your application, usually at the end. Often that's enough. It will give you enough information in the stat trace to understand where your application may have had difficulties, but it's not always the case that it's going to give you information about where the actual bug itself is located. So there's always a dislocation between where a bug resides in your software and where it actually manifests during the runtime, during execution. So core dumps, again, very powerful, but quite limited. So I have an example here of what I would say is a traditional remote workflow. And this is just an example. Everybody has their own workflows, their own ways of doing things. But I really wanted just to pull out here that you can see after the initial triage by the frontline staff, generally, if you can't resolve the problem there and then you're going to need to get into this information gathering phase where you can pass pertinent information back to R&D or back to the developers. They can propose fixes, send those fixes to the customer for testing. And if the problem isn't resolved at that point, you have to go through that cycle all over again. Of course, at this point, you have to then try and extend your hypothesis as to what's gone wrong, and you're going to have to potentially capture new debug data. And really, that's the big problem here, because capturing new debug data often requires changes to either the application or more intrusive and more time-consuming ways to find out information about what's gone on. So in the most simplistic way, you might have to re-instrument your application. You then need to rebuild it. You then need to send it to your customer. The customer has to then re-execute it and then send you the results back. This is very time-consuming, and particularly in situations where you have intermittent faults, then this can be really problematic. So, as I said, multiple iterations to solve that, to solve the failure. Now, the remote debug cycles can be, as I said, much longer than expected, and part of the reason for that is uncertainty as to what application state you actually need to gather. As you go through the process of understanding what goes wrong, you suddenly find that you need to know a little bit more about your application in the runtime environment, and you know, just trying to get that information from the customer site can be problematic. And particularly with reproducibility, you're going to have problems, you know, in terms of keeping that resolution time in a good place. There are other issues here, you know, IP sensitivity, getting information off your customer site and back to your developers, your R&D folks. It's going to be tricky. You know, customers are sensitive about their own IP. It's true in some sectors, more true in some sectors than others, but generally that's a problem. That's something that needs to be addressed. You also have limited access to your customer potentially. And certainly limited access to introduce new tools or scripts or what have you onto their system to be able to take real-time recordings. So all these issues kind of make the remote approach problematic, and we really want to find a way of circumventing a lot of these issues. So what we can take a look at is, you know, how do we circumvent these issues? So let's take a look at this workflow again. And again, it's, you know, representative. It's not going to be the same for everybody, but this capture new debug data section, really what we want to do is somehow remove that from the cycle, or at the very least reduce it in terms of time so that we can do it in a single pass. And the approach that we propose is one in which we are capturing that debug data somehow as part of the initial capture of logging and of, you know, core dump. So at that point where you might have done those kinds of activities, is there something else you can do which allows you then to have a totally holistic view of what's going on? And the workflow we're suggesting here is this, as you can see, we're capturing new debug data. We're doing the re-instrument and replay and recapture in a kind of a separate loop, if you like, and it's a one-off thing. At that point, R&D can create the fix again, send it to the customer for testing. But you know, we're confident that with our workflow, you'd be able to do that just in a single cycle and be able to resolve the problem there and then. So how do we suggest doing that? Well, we have an in-process virtualization technology called LiveRecorder that's capable of recording your application at a CPU instruction level. So very, very low level, small granularity. And it's able to capture the entire process history into a file, which you can then send back to your engineers for analysis. We have, as a partner application there, a replay engine or a debugger. It's actually a reversible debugger, so you can move backwards and forwards through it. So that's the general technology that we're suggesting you can use to reduce your mean time to failure. I'm going to talk a little bit about how this works in practice. So why LiveRecorder? You know, what is it giving you and your remote support workflow? The first thing it does is it effectively removes the customer from the debug cycle. Because you are capturing the entire process history in a single step, there's no need to go back to your customer and say, oh, we caught some information, we'd like to capture some new information from a different set of data structures, for example. Could you run, you know, the application again or the test case again, and hopefully find a path to resolution? What LiveRecorder workflow allows you to do is it kind of removes the customer from that, because once you have the recording file, you have everything that you could possibly need. Everything that happened during that program run in which the application failed is captured in that file. And there's no need to gather any more information. So you not only have information about the environment and the interaction of your application with the environment, but you also have the specific data that caused the issue. And often that's a problem trying to find that data, because again, customers can be a little bit sensitive about giving, you know, whether it's a design data or some other data which is causing the issue. They're very reluctant often to allow that offsite, which makes it quite difficult for you as a support engineer to get the actual data which caused the problem. So LiveRecorder fixes that, because all the data which caused the problem is in the recording file, and we can take a look at that at our leisure, basically. And this all comes to a point where we can say with confidence that the resolution time, you know, your mean time to resolution, is going to be much improved by this kind of workflow. So there are lots of different workflows that LiveRecorder can help with. So, for example, you could make a recording on the customer system. You captured everything that application did up to the point of failure. And then you can send that recording back to the developer. The developer then can take a look at the recording, use our interactive debugger, or potentially some post-recording scripting to analyze the recording and basically rerun what happened. It's a bit like a DVR. You know, once you have the recording, you can load it into the debugger, and then you can move backwards and forwards through that recording as you need to. You can look at application state at any point, and you can get a really good understanding of what your application did at the point of failure. Importantly, though, that recording is also going to contain the point at which the failure was introduced, so where the defect was introduced. So you have both the recording with the failure itself, so you can understand what the application state is at that point, but you can also then work backwards to the point where the, let's say, a memory corruption or a bad I/O communication caused the issue in the first place. So having that information and being able to send that back to the developer is a very powerful way of understanding what's going on. As we already mentioned, though, some of your customers are going to be unwilling to allow you to send those recordings back to the developer, to allow, you know, basically potentially their IP offsite. And in those cases, you can still use our technology, but in this case, you would debug on the customer system, and we support that workflow as well. We do so by providing you with a redistributable version of our debugger. So you can effectively use the same debug workflow using our reversible debug capability on the customer system as well. You don't need necessarily to send all that data back to your R&D. And that can all be done remotely. So there's no need to be physically at your customer. So I mentioned briefly that not only do we support this sort of interactive debug capability, but we also have an option to execute analysis scripts on the recording files themselves. And you can think of the recording files as being like databases, which you can interrogate and really build your own hypotheses as to what went wrong, and then prove or disprove those by taking a look through the recording with a script. So we'll take a look at an example of that in a moment, and you can get a good feel for how that might help you in your support interactions. One last thing, one last workflow that we recently introduced was the ability to combine information from your existing login with an interactive debug session based on the recording. So that would mean that you could take a line from your log, which looks a little bit suspect, and find out exactly where in the process execution via the recording file, where that log line was introduced. You can then, using the debugger, you can take a look at the application state, and at that point, you hopefully get to the root cause much more quickly. So there are a number of different ways in which you can use the recording technology to make bespoke, if you like, workflows for your customer support teams. So I'm just going to give you a quick demonstration of what that might look like in practice. This is very simple, so I really just want to show a very straightforward application and then show you how we might make use of the technology to get to the root cause. So I have a very simple application. Just run that so I can show you what it's doing. So this is pretty typical. We have an application which is giving us some login information, just standard stuff when everything's going well. Notice at this line that something's gone a little bit wrong because there's some internal consistency check which is failed. And the login is trying to tell us a little bit about what's happened. And it tries to be really helpful there by identifying both the source file and the line number where the fault occurred, and also what type of fault it is. And then in addition, we have a core dump. So this is not atypical. This is a pretty traditional approach to providing the information you need to resolve bugs. But what we can do here is better, because we can record this application running and provide us with our recording file. So I'm going to go ahead and do that. There are a number of ways, a couple of ways in which you can generate that recording. One is through an API which you can integrate into your application. That's really useful in terms of making the recording process as seamless as possible at your customer site. And indeed, you can make it sufficiently simple that you can have your customers generate recordings for you. So you don't necessarily even need to have frontline staff, either physically or remotely, at your customer. So I'm just going to give the recording file that we're going to generate a name, and then I'm going to pass it the same application that we just saw fail. So again, just want to emphasize that this application has no special API calls in it at this point. This is just the standard application. I've compiled it in debug just to make the whole thing a little bit more visible to you, but you can record optimized builds, release builds without debug information. That's not a problem. So let me go ahead and do that. So you can see that the behavior of the application hasn't changed at all. We've still got the same failure. That's important when we make a recording, that we don't change the behavior of your application. But we have a couple of extra lines here to let you know that the recording was made of, and the file called cache.undo is available for us to take a look at. So if I have a quick look at this file, see, I've just generated it. Now, this file itself is now really a portable artifact for capturing debug information. You can take this file and you can run it on any system that has our debugger installed. You don't need to have the original binaries of the application. You don't need to have any third-party libraries. You don't need to configure your environment to match the environment where the failure occurred. All interactions between that application and libraries, environment, and so on, are all contained within that recording file. So the recording file is really you know, a primary artifact for debug, and it contains, you know, every step of the execution of that process from the start to the beginning to the end. Okay, so what do we do with it? Well, at this point, once we've used the LiveRecorder technology to actually record, we can use our reversible debugger to take a look at it. And it's worth pointing out here that we have two versions of the debugger. One is the sort of desktop version, the one that you would use back at base, and the other one is a redistributable one, which you can distribute with your own applications, so that it's ready at your customer's system when needed. Both of them work in exactly the same way, so I will demonstrate how to make use of it. Okay, so I'm just going to load in the recording file into UDB, and it's worth noting at this point that UDB really is a drop-in replacement for GDB. So a lot of the commands are the same. Really, the only big differences are the ability to go backwards and forwards through your application, and obviously to load recordings. I'm going to put this into 2E mode so it's a bit easier to see. I'm going to set a break on main. And then I'm just going to run to that breakpoint. So rather than run, I'm going to continue, because we're not actually running the executable. We're actually replaying the recording file, and that's an important difference. So let me continue on. So we've hit the breakpoint. Now I can use standard GDB style navigation and functionality to move through the program and also take a look at application state at any point. So the big advantage of a reversible debugger is that we can do everything that we did forwards, we can do backwards. So now I can move backwards through my application and take a look at application state at any point. So my analogy earlier of a DVR recorder is, you know, you can see it here. It's basically your ability to scrub backwards and forwards through the application, taking stock of what the application state is at any point. And this works at a very low granularity. So even at the instruction level, I'm able to step instruction by instruction through the assembler, and we're able to go back and do the same thing. We're also able to take a look at registers and so on. So, you know, you have a lot of capability, a lot of functionality there to understand what your application is doing. Okay, so I'm just going to go back to the slides. Hopefully that gave you some idea of you know, the kind of opportunities for analysis that the combination of LiveRecorder and UDB presents. So let's talk about a few additional issues I mentioned earlier on. One is IP sensitivity, and IP sensitivity, particularly in a remote environment, is kind of difficult. It does depend on your customer, how willing they are to share information with you. But certainly my own experience is that many customers are not able to, just for legal reasons, be able to give you the sort of data that you would need to be able to solve the problem quickly. So it's hard to reproduce the problem without the customer data. I mean, that's a given. And as we've seen, the ability of LiveRecorder to include the pertinent data into the recording gives you quite a lot of leverage in terms of being able to solve that problem quickly. Of course, you also have, particularly when you work remotely, you also have an issue of exposing your own IP in terms of you know, debug symbols that you might need or source code. Certainly, you know, remembering if you do go to your customer site, either physically or remotely, remembering to remove those debug artifacts, those symbols. Obviously, you probably wouldn't include source code there, but remembering to do that's important. And failure to do that can expose, you know, internal workings of your application to third parties. So IP sensitivity is really an important aspect of working remotely, and we try to mitigate any issues there with a number of sort of toolings. So the first one I've mentioned already is a redistributable debugger. So essentially, this is something that you can either include in your application itself, so in your distribution, sorry, or it's something you can download at the customer site if you need to. And the big advantage of using the redistributable debugger is that if your customer doesn't allow you to take the recordings off-site because of their concerns about IP, then you can actually do the full debug session actually on the customer's site directly in a way that means that no data is actually leaving the customer. And that's a big deal because it means that you can use a tool that you're comfortable with, that you're familiar with, and a workflow in terms of interactive debugging, which you're again going to be comfortable with and familiar with, and that's going to help you get to resolution much more quickly. So I think for on-site debugging, certainly you would use our redistributable debugger to load recording files, but you can also use it just to attach to the application directly. So if you know your workflow doesn't really support the generation of recording files, and sometimes that is the case, then you can use our reversible debugger to attach directly to the application, and you get the same functionality in terms of being able to move backwards and forwards through your application. So again, this is a very powerful tool that you can use remotely on your customer system. A big advantage of the redistributable version of our debugger is it doesn't require any external access to a key server or a license server. Basically, it's fully self-contained, and you can use it as and when you need to. So I mentioned handling debug symbols earlier. So you need to have debug symbols if you want to have a meaningful debug session with an interactive debugger. But it is your IP. So one of the advantages of our redistributable debugger is it's possible to encrypt your symbol files in a way which only our debugger can decrypt. And this is nice because it means that you still want to tidy up after yourself when you're working remotely. But if a symbol file did become kind of left over, then they're never going to be left over in a clear state. So it's not going to be possible, even if the file exists on the customer system, for anybody to take a look at the components or the contents of that file. So the symbol files are decrypted at load time by the debugger, and then after your debug session, everything is left in a decrypted state. So that's a big deal in terms of protecting your own IP when you're working remotely. Then finally, I guess we have, penultimate, I guess, capability, something we call log jump. I mentioned earlier that we understand that you put a lot of effort into creating these rich logging capabilities, which try to figure out what information do you need in order to solve the problem. And of course, when you're putting those logs together, that logging functionality together, you're trying to think what it is that you're going to need in the future. And as the application becomes more mature, that logging capability is going to also become more capable. The problem is that most bugs happen because of things we didn't think of, and if your logging is only capturing information about your expected failure modes, when you get an unexpected one, there's a good chance that your logging is not going to be sufficient to help you out there. The issue then is, if you can find in your log where things are beginning to go wrong, even if the logging doesn't explicitly say what's happening, you have a way of kickstarting your debug investigation much more efficiently, because you can take the line in which the debug happened, the line in the log in which the problem occurred, and you can then jump directly in the recording file to the point where that log was generated. So you can then work backwards from that point and understand how it was that your the logging captured that information, put it out to the screen or to a file, and from there you can hopefully get to the root cause of the problem. So this is what we call log jump, and it's really a very powerful way of combining different debug workflows into a single activity. So the final thing I wanted to share with you is something called post-recording analysis. I mentioned earlier that the recording file itself is essentially a database of all events, all signals, all memory changes, all instructions essentially that your application executed. And sure, you can take a look at you know, the specific registers with the interactive debugger. But another way of approaching a debug session is to do a sort of printf style debugging. But the big advantage of this is that you don't have to do a rebuild, because once you have the recording, once you've captured the problem in the recording file, you've got it forever. You know, and this is a big deal for things like inconsistent failures. Once you've got that failure in the recording file, then you've got it forever, and it means that, you know, any analysis that you do on that recording file is always going to contain the bug. And in terms of reducing your mean time, that's important, because mean time to resolution, that's important because it means that you're not having to go through that debug cycle of re-instrumenting, rebuilding, re-executing, and so on. So how does it work with the recording file then? So we have a feature called post-failure logging, and the idea there is that we, I'll show you a small demonstration in a moment, but we have a text-based, what we call a probe file, and the probe file contains information about the data structures that we want to capture from the recording. And we tell in that profile, we also tell the post-failure logging script that we want to capture that information at certain points in the application's runtime. So this is very similar to printf debugging, but the big advantage here is that if we discover that we haven't captured the information that we need to move on with the analysis, unlike in a more traditional workflow where, like I say, you'd have to re-instrument, recompile, rebuild, and so on. With post-failure logging, because you already have that failure in the recording file, all you need to do is make a change to the profile and then just rerun the script. So, you know, you don't need to go back to your customer and ask them to rerun anything. You have everything you need, providing that failure is actually in the recording. You have everything you need to understand what's going on. So the post-failure logging capability is actually built on what we call the automation API. And this underlying API is a very powerful way to control both the debug and analysis stages. And you can produce some quite complex tooling just using Python scripts to the point where you can potentially send them to your customer to run themselves, and for them to get you, either send you back the information, or if you're not allowed to take that information out, then that gives you an opportunity to do it on site. One of the big advantages of this is that the output is going to be in clear text. So if there are some concerns about IP leaving your customer's system, you can show them the contents of these log files, and you can say, this is what we want to take away, and hopefully that's going to be sufficient for them to allow you to do that. So let me just show you an example of how that might work. So I have an example here. It's a simple Fourier transform program. So if I just run this, I can see that in the top line we have the function that's being generated. It's a 2-component sinusoidal function, and it's producing, you know, a time series that looks something like this. And then the bottom half is the actual Fourier transform, or the FFT of that. And one thing you'll notice straight away is that despite the fact that we have a 2-component signal, actually the Fourier transform is only showing one of the components. For those who are not familiar, the 2 components are reflected down the middle. So if we just look at the right-hand side of this graph, you can see we've only got one component. If I run it again, the second component has become visible. So that's interesting because the application itself didn't fail. We didn't get any errors. It just did the wrong thing. So what I really am interested in here is how do I grab information from my application, data structures or something like that, and how do I compare those data structures or the values of those data structures between different runs, between a working and a non-working run. So I mentioned that we have this post-failure logging, and actually what we have is a workflow that allows you to capture recordings of the runs. So let me just show you what we have. We have an undo recording of the broken run, and we have an undo recording of the working run. And the workflow here is for us just to compare those two logs, those two recordings in some way. So we need, these are binary files, you can't just look at them in clear text. So we need to find some way of extracting the important information from those recording files. And the way we do this is through the profile. So if we have a quick look at the profile. So it's very simple, it's text-based. So I think the one line that we're really interested in here is here. What we're asking the script to do is to print some information. We want to, sorry, this line here, sorry. We want to capture information at this location in the application. So in this source file and this line number. So, this is familiar stuff. It's just a breakpoint. At that point, we want to print the values of these internal data structures. We can do all sorts of other things. We can do asserts and so on. So, there's some flexibility as to what we can do with this. And again, we'll see in a moment that this will generate a log file, but if we find on further analysis that there isn't enough information in these 4 data structures, then we can just add them onto the line and just rerun the script. And again, rerunning the script doesn't mean rerunning the original binary. This script is being run over the existing recording. So there's no need to re-instrument rebuild the application. We're doing everything just from the original recording. So if we have a quick look at the logs which I created earlier from these recording files, you'll be able to see that it's very simple to it's very simple to see the the information in a behavioral sense, in a time related sense, and log files are always really useful for showing how to showing the behavior of your application, the general behavior of your application over time. So our log file here is really showing us, yes, on this particular line, I'm just choosing one at random. We have captured this information here, these data structures, the values of those data structures at this point in our application. And there's a couple of numbers along the line here. This is the thread number, and this is what we call the time index. One thing I haven't mentioned up to this point is that, your application, your recording of your application, unlike a normal sort of debugger where you're stepping backwards and forwards through the source code, in our interactive reversible debugger, you're actually stepping backwards and forwards in time as well. So each point has a unique time index, and this is what's being printed out on the left-hand side here, and that's useful. So I have both my log of my working version and a log of my non-working version or broken version, and what I'm going to do is just compare those logs. So I'm just using a standard diff tool, happens to be meld in this case, but obviously it can be anything at all. And if I just scroll down to a point where you can see, where I'm comparing the data structures in each case, and they're the same. If I just scroll down to the point where there's a divergence in the values, so you can see on the right-hand side in the broken version of the log, you can see that we have this -1 value for this internal variable, and that seems odd because these look like real values up to that point, and then all of a sudden it's all -1s, -1s. And when I look at the working version of the same so the log of the working run, we can see that actually that doesn't happen. So this looks like a a really key kind of understanding of what's happening. So if I just scroll that over, so now that I know that at some point from my printf style post failure logging output, I know that something odd is happening at this point. I can go over to the number and make a note of that time index. I can quit out of the diff tool, and now I can use the interactive debugger to load up the broken recording, because we still have the recording from previously, and put some TUI mode, and then I can type in the time index that we took a copy of earlier, and this is going to take me directly to the point at which that value was caught. And here we are. So let me just scroll that down. And now I'm into an interactive debug session, and I can go forwards, I can go backwards, I can step into functions, and I can look at values at all these points. So at this point, then I can get into, as you can see, the actual bug itself is a kind of synthetic thing that we've added just for the purposes of the demo, but it shows you can go directly to the problem with this combination of behavioral analysis and interactive debug session. Okay, so I think that's more or less everything I have to show you. Just to summarize, the key thing for supporting remote debug, remote support, is reducing that time to resolution. You want to be able to deliver the fix to your customer as soon as possible. And we provide the tools and workflows. We've had a look at some of the tools and workflows which can help you do that. And certainly having workflows which are consistent, they may be based around grabbing a recording, or maybe attaching the reversible debugger to the failing application. That's important that you have those tools at hand, whether you're physically there, or even if you're not there physically but remotely. If you include the redistributable debugger with your own application, that means you have all the tooling that you need actually on site, and there's no need to upload anything else. And of course, very important part of this whole conversation is, particularly in the remote workflows, is how do you figure out IP? Many customers are going to be sensitive to the way that you handle their IP, and therefore it's important that you're able to demonstrate to them that you're doing everything you can to avoid exposing that IP. So hopefully that has been useful, and if you do have any questions, then please let me know.